Good afternoon, everyone. In this lecture series, we are going to discuss about the unit network theorems. We have discussed about various types of the theorems in this unit. The next topic we are going to discuss about the maximum power transfer theorem. So, what do you mean by maximum power transfer theorem means? Suppose if the AC voltage source will deliver maximum power to the variable complex load, at the same time the load impedance should be equal to the complex conjugate of source impedance. How much of the maximum power that will be produced in the load? For example, if we take the two-terminal linear circuit, we are having two terminals, that is A and B. So across the terminals, how much of the load resistance, how much of the load that can be calculated? From that load, how much of the power that has been transferred? So this is the thing we are going to discuss in this maximum power transfer theorem. So what do you mean by maximum power transfer theorem? We have discussed, and the next thing we are going to discuss about what are all the steps in the maximum power transfer. The first thing, suppose in the given problem, or if the given in the given problem, the first step what we have to identify is we have to disconnect the load resistance. As already I have mentioned that we are taking the load terminals across A and B. At the same time, we have to disconnect the load resistance from the circuit given. The next one, we have to calculate the Thevenin's resistance. Already, we have mentioned how to calculate the Thevenin's resistance in the previous video. So, to calculate the RTH, we have to short circuit the independent voltage, and the independent current source will behave as an open circuit. So after measuring the Thevenin's, that is RTH, we have to calculate the Thevenin's voltage across the open circuit load resistance terminals. So after that, we have to apply the maximum power transfer formula. So these are all the steps we have to take in order to obtain the maximum power transfer theorem. So in the problem, we are going to find the maximum power that has been delivered to the that is our load resistor RL of the circuit shown in the figure. The supply is given and the various resistors has been connected, and how much of the current that has been flowing through the circuit will be here. They have mentioned as 40. So as I have mentioned in the steps, we have to calculate the Thevenin's equivalent circuit to the left side of the terminals A and B. At the same time, here the Thevenin's voltage can be measured as 200 divided by 3 voltage. So already in the circuit they have given as 200. Next thing is we have to calculate the Thevenin's resistance, that is RTH is equal to 40 divided by 3. So this is what we are going to measure the things. So already we know that we have to disconnect the load resistance. So here we are replacing the part of the circuit which is left side of the terminals A and B as given. So this is the resultant circuit diagram is given in the following figure. Already the values has been mentioned in RTH and VTH. The current flowing through the RL will be the load resistance we have disconnected. So in step 2, we have to measure how much of the power that will be delivered to the load resistors by using the formula. So we know that the formula is VTH squared is equal to 4 RTH. So here we know that VTH is equal to 200 divided by 3 and RTH is equal to 40 divided by 3. Just we are substituting in the formula, we are getting 250 divided by 3 watt. So the maximum power that will be delivered to the load resistor will be 250 divided by 3. So this is the mind map we have discussed. The first thing is in the maximum power transfer. What all the steps we have to do is we have to disconnect the load resistance. We have to calculate the Thevenin resistance, Thevenin voltage, and we have to apply the maximum power transfer formula. While calculating the Thevenin's resistance, we have to short circuit the voltage source and open circuit the current source. The mathematical formula already I have mentioned this in the previous problem we have discussed about in order to find the maximum power transfer. Thank you.